Hi my friends, today we study this mechanism with a wheel, a sliding lever and a pendulum. When you rotate the wheel, you can see how is this pendulum moving in space. This mechanism as an Inventor assembly with components was posted by me on GrabCAD in 2016. Let's see where is this placed. But before this, you see fastgroup.ro is my site. When you click on tutorials, you can find everything about our tutorials. Yes, this is the first one, number 26, which has some files attached to it. The tutorials without a presence in this list don't need any files, because everything is created in the tutorial itself. Yes. Okay, now if I write here GrabCAD, home, I see a lot of projects placed here by CAD creators, and a total of 8.5 million of viewers and creators, with over 4.5 millions of CAD files included in this project. Free, all of them. If you want to download files from this portal, you have to join the community. This means that you have to create an account, an email and a password. When you are already joined to this community, you have to log in. My profile appears, as you can see. Now, supposing I am you, I click on Engineers and I write here a name. For you is a name, for me is my name. Click on my face and click on my models. Go down and select this very model. You see, you have occasion to like this, and you can download every file of from this model. You can explore all pictures, or you can use 3D viewer to explode the assembly, and so on. Important is that you can download because you have an account. Yes. If you click on this link, you'll see the movie. Did you like it? Okay, if yes, let's download all these components. To do this, I click on Download Files, and I'll find in my File Explorer directory Downloads, which now is empty, all that files. Let's do this. Download. You see here, everything was downloaded, and now I see this. I extract everything here, and now I have on the disk of my computer the assembly, all components and pictures, everything which was listed in GrabCAD. We'll use them to create our own assembly, and then we'll apply dynamic simulation to see that movement as in the movie. You should know that all the Inventor files you download from my GrabCAD projects were created with the 2014 Inventor version, so now in 2021 you can open them without worries with recent Inventor versions. Now let's create the assembly. New, standard millimeters IM, and we place the first object, which must be grounded. This is plate 2 axis, grounded at origin. I place another object, the wheel. I place it somewhere in the air. Now I want to apply a procedure which you know, to change the lights, because I don't like how it looks in this presentation. 2 lights, settings, (27), 11, the other light, not gray but white, and upper 66 and somewhere 66. I want to be here, and only 43. You see, there is another luminosity which we like. I'll apply also shadows. You see, now I have shadows here, so that we can have a nice presentation. Good. Let's apply constraints. The first is insert this circle to this circle. Apply. Next is the sliding lever, this one, and there is a mistake here. I know it, but I didn't want to change parts because they are other version of Inventor. I work with 2021 and I don't know which version you use, so let's modify. What is the mistake? If I apply measure with M from Monaco, I see that this diameter is 12 and this is 10. And these two parts are connected with a shaft, small shaft. So I double click this, I go to the hole of 10 millimeters, double click, and I change 10 with 12. This is all the modification. Return. You have to make this modification. Now I constrain with insert this over this. Yes? Okay. Place the shaft of 12 and constrain with insert aligned on this circle over this circle. Now 12 is the hole. There is another mistake, I'll tell you. I repeat, I didn't want to change this parts before because I use now another version, a newer one, and I didn't want to offer you parts made with the last version in order to download for yourself and use your own version of Inventor without problems. Good. Next part is the hole shaft, this one, which must be constrained over this face. Yes? So constrain, insert these two circles, apply. Now I make another constraint, but we'll see that this is an over constraint. Mate, axis on axis. Okay, we have no error message. Yes, we can rotate without problems. Everything seems to be okay. But when we'll go to dynamic simulation, we'll see that there are problems. And when you have problems, you learn better than when you don't have problems. This is my vast experience with students like you, my friends. I place here a nut to fix the hole shaft, as it's called. So place, this is the nut, not in the content center but in your furniture, downloaded as I told you. I place this on this circle. Okay. Now another object is the rod, double threaded. The hub and the pendulum itself, pendulum of 1 kilogram. This is the second problem because this is metric 12 and this is metric 10 on both sides, ends. This is 10 and this is 12. M from Monaco, and we see this is 10 and some, and this is, excuse me, this is 8. Oh, 10 is this and 8, not 12. Let's see once again. This is 10 millimeters, yes? So I have to modify this. 10 millimeters, 10 millimeters, and this is 8 metric. Double click on the rod. You see the other are transparent, and I change the sketch, initial sketch, changing this in 11 or 12 and the ends in 10. 10 is also here because they were constrained. Finished sketch will receive a message. Yes, because now the thread which we applied there with the tool thread is not accepted. So I have to change both thread, double click on it, and isometric profile to 10. Okay. Again, there is the other end, accept. This is not with problem, this is with problem. Double click, and this is ISO 10. Okay, no messages. Return from part to assembly, and now we place with insert the pendulum on the rod, apply, and hub on the rod, apply. Next is also with the insert, the hub with all this sub-assembly on the sliding lever. This is the sliding lever. Okay, now we have other parts here. I have to place this aligned with this to be like in the picture. So I constrain from the pendulum the plane, this plane, to be aligned with the plane of the hub. Hub is this, and the plane is this one. Yes? Okay. We want to have these two aligned. Metric 12 is also the same knot, constraint with the insert at this position. Okay. Well, I think that everything is okay. As you can see, we can rotate the wheel, we can rotate the pendulum, and nothing is in collision. I was very careful with this by dimensioning. See, not collisions. Look, yes, I make something now in order to have the same start point. with our dynamic simulation as in the movie. This must be aligned with this. So I select the wheel, plane of the wheel, this plane, to be parallel with this face. Yes, apply. And also this one I want to be vertical. Yes, to be like this, but strictly vertical. So I use constraint for the rod to be perpendicular on a plane of this. Yes, the sliding lever. This is okay. Now I cannot rotate this, I cannot balance the pendulum, so this is the standard position. Oh, but we want to have mobilities here. Yes, yes, I suppress the both constraints. That was the first, and the wheel this is suppressed. Yes, and the other is for the rod. Where is the rod? Rod is here, and this is suppressed. I am very careful now to not move anything here. Yes, why? Because we go to dynamic simulation and we receive this great problem. Over constraint by 2 degrees. Oh, we have experience with this problem from our past tutorials. Take a look at my tutorial number 179 to see the procedure. Now I repeat that procedure. I go to mechanism status and I see here that a translation along the x-axis and the rotation about the y-axis are over constrained. We know where is the problem. I told you about this constraint of this the axis of sliding shaft and the axis of the hole. Instead of this constraint, which takes 3 degrees, we have to constrain a single degree. Yes, to do this we go back to the assembly, we select the sliding lever, and we have this made, which must be deleted, and then to constrain the axis of this with a plane which contains the axis of the hole. Let's do this. Constrain the axis, I said the axis of the sliding lever to be constraint with this plane. Yes? That's all. Okay, let's see what happens now. Environments, dynamic simulation, and we don't have any message here. Yes? Because only 1 degree was constrained here. Good. Now I apply the gravity, double click, and I select this to have a direction of the vector of gravity. Now I'm sure that this is it function the gravity, so that when I rotate the wheel I have everything in its dynamic. Control Z to obtain the same position like in the past, and now I apply imposed motion of rotation to this wheel. Yes? To do this, you know the procedure. We select the joint between the wheel and the part. Oh, I didn't place here a shaft identical with this. Everything is working, yes, but I want to be okay. So I place now the 12 millimeters diameter shaft, and I'll place it with constraint, insert a line here. Okay. For the dynamic simulation, the joint matter. Yes? Not parts, but joint. So when I go back to the dynamic simulation, I have no messages, and I go to that. This is the joint. I select it, I select properties, DOF 1 rotation, a single degree of freedom. I select imposed motion. You know from my tutorials 179, 180, but also in the far past, how to proceed. I go here and I select at 1 second to have the value of 165 to be like on GrabCAD. You see, now we have the diagram of speed. 1 second, and the rest is uniform speed. Okay. Okay. I change this 1 second with 10 seconds. I click on Assembly, Home, and let's see what happens. It must happen exactly what you have seen in the movie, but at the other speed. Not exactly, but it is okay. And now I want to see the trajectory To do this, I go back, I get out from construction mode, finish sketch, and I'll create a hole in this pendulum weight by creating in this sketch a small circle, F7, circle of 2 millimeters diameter, 2 millimeters. Finish sketch, extrude both the directions and through, and of course cut. Now we'll have here a hole. Okay, this is the hole. Now I have an element, a feature to be used for drawing the trajectory. Environments, dynamic simulation, F6 to have the same view, and trace. I want to be green, and I have to select something. I select that hole. We wait a little here and we select vertex. This is the point for trajectory. Okay, and now start. It is not exactly as the movie, but is real and suggestive in my opinion. If you take a look to the trajectory as a 3D curve, you see that it covers a zone inside 2 cylinders, I suppose. Yes? Okay. That's all for today. Thanks for watching. Bye bye.